So welcome, guys. This is your essential questions for today or this week. Module 2.1 is what we're going to be diving into today. The first parent graph function is the absolute value function. What is a parent function and how does each change affect the graph of the function are the two questions we're going to answer today. So this is the parent function, okay? Absolute value of f of x. And these are your parent points. So whenever we are graphing, right, we're starting off with these points and with this graph. Okay, and then we're going to dive into what each change does to the graph. We talked about it yesterday through an example on Delta Math. I'm going to formally do notes today. So, okay, so this is your absolute value function. All right. So if we look at this, a vertical shift up is represented by the number that's outside. We're adding, right? We're adding, so it's a vertical, it's a shift. It's on the outside, so it's up or down. If it's plus, if it's a +2 that we're adding, right? If we're adding the number, we're gonna vertically shift it up by that number, and then I'm gonna put k units. So in general, it's gonna be f of x equals absolute value of x plus or minus k. All right, so if it's minus, it's going to be a vertical shift down by 3. If it's a plus k, we're going to shift it up by 3. Okay, so this means that we're going to shift this whole thing up by 2 units. Actually, to describe this guy here, it's going to be a vertical shift up 2 units. Okay. So notice that in these points, this one here, these points here are your parent function. Okay. So these points are exactly the same as our previous slide. And so if we're going to shift this whole graph up 2 units, that means we're going to be adding. This is going to be x. This is going to be y plus 2. So notice that the x values from our second table is the same. -2, -1, 0, 1, 2. And then 2 plus 2 equals 4. 1 plus 2 equals 3. 0 plus 2 equals 2. 1 plus 2 equals 3. And 2 plus 2 equals 4. That's the only changes that we're doing. Okay? If it's a plus on the outside, it's a vertical shift up 2 units. Okay? In this case, it's 2 units. And we're just going to be adding our y value by that number. Okay? Along the same lines, if we're subtracting 3 on the outside, this is going to be a vertical shift down 3 units. Meaning my x comma y, my parent points here, turn into x comma y minus 3. Okay? So all we're doing is just we're subtracting 3 from our y value. So again, the x values stay the same, -2, -1, 0, 1, 2. And my y values, 2 minus 3 is -1, 1 minus 3 is -2, 0 minus 3 is -3, 1 minus 3 is -2, and 2 minus 3 is -1. Okay? Yeah. All right. So that's how these changes work, right? Okay. Any questions on that? No? We're just adding or subtracting our y value by that number. Okay. That's a vertical shift. Horizontal shifting, remember you got to think opposite. Okay. So this one would be f of x equals absolute value of x minus h. Okay. And we're going to shift the graph left or right k units. Okay. So here we have a -2 on the inside of my function. Since it's on the inside of the function, it's going to be a horizontal something. And if it's a plus or a minus, it's going to be a shift. So it's a horizontal shift by 2 units. But we have to remember, we have to think opposite. So if it's a -2, you automatically think we're going to the left, correct? But it's actually to the right if you think opposite. Okay? So please, please, please remember to think opposite. Okay? So if we're moving our graph to the right 2 units, that means that we're adding x by 2, right? We're increasing our x value by 2, so our new point is going to be x plus 2. Our y values stay the same, but our x values increase by 2. So notice that my y values stay the same. 2, 2, 1, 1, 0, 0, 1, 1, 2, 2, right? Y values stay the same, but my x values are added by 2, so -2 plus 2 is 0, -1 plus 2 is 1, 0 plus 1 is 2, 1 plus 2 is 3, 2 plus 2 is 4. All right? And then once we graph these points, you essentially graph that function. Okay? Our next example is a +3 on the inside. So since it's on the inside, it's a horizontal. Horizontal. Since we're adding, it's a shift. Okay? This is when you have to think opposite. Since it's a +3, you think it's to the right, but it's actually to the left if you think opposite. 3 units. Okay, horizontal shift to the right, 3 units. And if we're moving it to the, to the left, 3 units. And if we're moving it to the left 3 units, that means we're subtracting by 3, right, to our x value. Our x value because it's horizontal. Okay? So again, the y values all stay the same. 2, 2, 1, 1, 0, 0, 1, 1, 2, 2. My x values are decreased by 3. So x minus 3. So -2 minus 3, not -4, it's -5. Oh, I think I just subtracted by 2. It should be 3. So all of these numbers are incorrect. -1 minus 3 is -4. 0 minus 3 is -3. 1 minus 3 is -2. 2 minus 3 is -1. Okay? So we're actually shifting our graph over to the left 3 units. Yeah. Okay? Questions on horizontal shifting? No? All right. Okay. We're good. That is shifting. Okay. Vertical stretch or compress. The description is vertically stretch or compress by a factor of, I want to label it A. All right. In this form of f of x equals A absolute value of x. Okay. So here in our first one, we're multiplying it by 3 on the outside, right? Since it's on the outside of our function, this function here, we're vertically doing something. Since we're multiplying, we're stretching or compressing. And since we're multiplying it by 3, it's going to be a vertical stretch, right? We're stretching out the graph. So it's a stretch. BAFO. That's by a factor of 3. Okay? So if we're vertically stretching something out, we're actually multiplying our y value by 3. So this is going to be 3y, okay, from our parent point. So -2 stays the same. 2 times 3 is 6. That's how I got 6 here, right? One times 3 is 3. 0 times 3 is still 0. 1 times 3 is 3. 2 times 3 is 6. All right? Questions on that? No? So if the second example is 1/2 x, right? It's half of x. So what do we do here? It's on the outside, so it's vertical. And if we're multiplying it by 1/2, is my picture or is my graph, is it going to stretch or is it going to shrink? It's going to shrink, right? Or compress, correct? So this is a vertical compression. And by saying compression, we automatically know, class, that we're shrinking it, right? Yeah. If we say compression, we're already shrinking it. So by a factor of 2, we're shrinking it by 2. We're not shrinking it by 1/2. We're actually shrinking it by 2. Okay? So does that make sense? Yeah. If we're vertically compressing something, we already know that it's compressing. So we don't say by a factor of 1/2. We say by the factor of 2. Because we're shrinking it or we're compressing it by a factor of 2. Okay? So my x values stay the same. My y values, I'm going to be dividing it or multiplying it by 1/2. Okay? So 2 times 1/2 is 1. 1 times 1/2 is 1/2. 0 times 1/2 is still 0. 1 times 1/2 is 1/2. 2 times 1/2 is 1, right? Notice that with the vertical stretch or compress, the vertex of the graph, which is at 0, 0, or that center point of the graph, right? It's a V, right? And the tip of the V, it stays the same. So we're stretching it from that point. Okay, I believe in integrated 1, you guys learned about dilation, yeah? And that point of dilation is going to be the vertex. Okay, so we're dilating it, stretching it, or compressing it by that vertex. So that vertex does not move at all. Okay. All right. Our next one is a horizontal compression or stretch. Horizontal compress or stretch by a factor of B. All right. So you have to think opposite. So since this example here, we have 2x on the inside of my function, right? So on the inside, the 2 times x, it's going to be a horizontal something because it's on the inside. We're multiplying it, so it's a stretch or compress. Okay, if we're multiplying it by 2, you guys think, what? Is it a stretch or compress? Stretch. You guys think it's a stretch, right? Because we're multiplying it by 2. But since it's a horizontal something, or since it's on the inside, it's affecting my x, you have to think opposite. All right? Think opposite. So if you think it's a stretch, it's actually a compress. Okay? BAFO by a factor of 2. So since it's a horizontal, it's affecting my x values. And all we're doing here is we're multiplying this by a half, by 1 over 2. Okay, so this is 1 over 2x. Okay? You got to think opposite, right? It's a compress, so we're shrinking it horizontally. So -2 turns into -1. -1 times 1/2 is -1/2. 0 times 1/2 is still 0. 1 times 1/2 is 1/2. 2 times 1/2 is 1. And my y values stay the same. Okay? Vice versa, or similarly, 1/2 x, my second example here. We're horizontally doing something because it's on the inside. You guys think because we're multiplying it by a half, it's going to be a compress, but it's actually a stretch if you think opposite. BAFO by a factor of 2. Okay, so we're multiplying, this is a stretch, we're multiplying my x value by 2. So -2 times 2 is -4. -1 times 2 is 2, or -2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. Okay? Does that make sense? Okay? Yes. Yes. All horizontal things are opposite. All right? Now our reflection class, whenever we're reflecting, we're only reflecting it over the x-axis, this axis here, or over our y-axis, this axis here. Okay? That's all of our options right now. All right? So a reflection over our x-axis means a vertical reflection. We said it's a vertical reflection. But this is going to be f of x equals negative absolute value of x. Okay? The negative's on the outside, so it's vertical. So it's going to be a reflection over our x-axis. I already gave you the description here. Okay? So if it's a vertical reflection, that point 1 on my graph like that becomes negative 1 here, correct? This point would vertically reflect to here. This point would vertically reflect to here. My x values stay the same. My y values will just be negative. So my new points is going to be negative y. So all I did here was I put negatives on the y value. Okay? All right. Oh. This part here, the horizontal reflection. Oh, you know what? Let's not erase it like that. Let's just put a plus here. These should be pluses. Okay? A horizontal reflection, I'm not going to really cover too long about. Okay, it's just that. If we're multiplying our a negative on the inside of our function, it's a horizontal reflection. And if it's a horizontal reflection, class, we are multiplying, or we're changing our x values, right? So this point here reflects it to that point there. Okay? It's a reflection over our y-axis. So if our parent function, let me go back to the first slide. If our parent function here is a horizontal reflection, what do you guys notice? Wait. What do we notice? This point reflects to that point. This point, 1, 2, 1, 2, reflects to that point, right? That's a horizontal reflection. We would get the same graph. Yeah? This line here would just be reflected and be looking like that, and vice versa, right? So we would get the same graph. So essentially, in this graph here, the horizontal or the reflection over the y-axis doesn't really do much. Doesn't do anything at all, actually. Okay? So it should be the same thing. Same point. All right? Questions on that? No? So here on Desmos, we have absolute value of x, right? If you guys can see that. And our parent points are 0, 0. There's 2, 2. You guys, 2, negative 2, 2, negative 1, 1, 1, 1, and 2, 2, right? I'm a little bit off, but you guys understand the point. Okay. What happens when I add 3 on the inside of the function? Horizontal shift to the left or to the right? To the left, 3 units. So from my parent function here, you see that it went to the left 3 units, right? This 0, 0, 1, 2, 3. Okay, became 3 comma 0. All right, that 0, 0 became negative 3 comma 0 because we went to the left. Okay. How about negative 3 on the outside? Vertical shift down 3 units, right? So this point at 0, 0 became 0, negative 3. Okay. 2x, 2 absolute value of x. It's on the outside, so it's a vertical, right? Stretch by a factor of 2, correct? So it's going to get skinnier. And that's what it is. It got skinnier. So this point at negative 1, 1 became negative 1, 2. All right. This one here went fatter because of the vertical compression by a factor of 2. So you guys see how it went wider? This point at negative 2, 2 became negative 2, 1. All right, negative 2, 1. Okay. Same thing with the 3x on the inside. That's a horizontal compression, correct? So it compresses everything. So actually, you know what? Let me change this number to 2. This guy here, and let me change the color up on this. Notice that I have 3 graphs, right? Notice that a vertical compression or vertical stretch by a factor of 2, the green one, is the same thing as a horizontal compression by a factor of 2. They're the same exact graph. Yeah? Okay? So they're alike. So that's why I don't really deal with, in this class, we don't really talk about horizontal compression or stretches because that's the same thing as vertical. Okay? But FYI, this one here, 1/2 x, it's a horizontal stretch, correct? If we're horizontally stretching something, it's the same thing as vertically compressing something. Does that make sense? Yeah? So this graph and this graph should be the same. You guys saw that how it got a little darker? Yeah? That's the same exact line or the same exact graph. Okay? And a negative on the outside means a reflection over the x-axis, meaning that it's going to look like this. And a horizontal reflection is going to be the exact same graph as your parent function. Okay, parent function here, horizontal compression there, or horizontal reflection over the y-axis. Okay, cool. All right. So the general rules of graphing. Okay, I'm gonna type while I talk. The first rule here it must be you must graph or you must perform reflections and stretches or compresses before shift. Okay? Or in other words, shifting the graph, shift the graph last. The reason for that is because the vertex, the 0, point, remember, is that point of stretches or point of compresses, or that vertex does not change with a vertical shift or a stretch or compress or even reflection, right? That vertex stays put during stretches and compresses and reflections. The only time that the vertex shifts or moves is when we shift it. So we want to place that vertex last, do all the transformations, and then move it. Okay? The second one, you must graph each transformation. Okay? You might have 5 different graphs on one coordinate plane. Okay? It might get messy. You might have 5 different transformations. Okay? But I need to see the work that you do. All right? Okay? So those are the 2 graphs or 2 rules when you're graphing. Any questions on that? No? We did our Delta Math example yesterday. So more or less it's the same thing. All right? That's all I have for this lesson. And I will see you on the next lesson.